Good morning, students. This is Anjali Diwalkar. Today I am going to teach you about composition of forces. Okay. Actually, composition of forces means finding out resultant, right? Composition resolution means finding out components of a force, and composition means finding out resultant of a force. Okay. So I'll tell you, we'll discuss in a detail finding out resultant from composition of forces, right? So what is outcome of a composition of forces? If we compose means what? We are going to find out the resultant of the your given force system, right? So basically there are two methods to find out the resultant. First one is use of law of parallelogram, and a second one is general method. Second one is general method. In use of means in a parallelogram law, we are having this formula r is equal to under root p square plus q square plus 2pq cos theta, right? I'll draw the diagram just to explain you. Generally a horizontal force is a p, right? If I draw a parallelogram, which is this line is parallel to this line and another one is parallel to this, right? Then if I join these 2 points, this is nothing but your diagonal, which is nothing but a resultant of a given force system. So inclination between them, P and Q is theta. The inclination between given two forces is a theta, and P generally should be horizontal. It is quite easier to work out if we use P horizontal, right? Then if I want to find out the inclination of resultant with horizontal, we'll mark it as a alpha. So tan alpha is equal to q sine theta divided by p plus q cos theta. This is the formula, right? Again, alpha is the inclination of resultant with horizontal force. Q and P are a given forces. What does parallelogram law says? If a two adjacent forces are given to you and they are representing adjacent sides of a parallelogram, then their diagonal is nothing but a resultant. So by using that law, we have drawn this diagram and this is our formula, right? But there are some limitations for your parallelogram law. Only two forces should be there. Two forces should be there. If more than two forces are there, then law of parallelogram doesn't work, and they should be concurrent. If another force system is there, say two forces are there and again they are parallel to each other, parallelogram law can't answer you. So concurrent forces should be there, and that too they should be only two in a quantity. More than two are there, then we are supposed to go for general method. What is formula for that? R is equal to under root summation fx square plus summation fy square. What is summation fx? Summation fx is algebraic summation of all horizontal components of a forces, right? What is summation fy? Similarly, algebraic summation of all vertical components, right? All vertical forces or vertical components, we can say, right? If even in a given force system, say this is your coplanar force system, in this plane so many forces are acting like this. Few are horizontal, few are vertical, right? Few are inclined one. Inclined by theta, this is P, Q, S, this is also inclined by alpha, then this is T, this is U, this is V, right? These many forces are there. Here, few assumptions are to be made. First assumption, instead of assumption, we must say sign conventions. If a force is going rightward, if force is upward, and it is giving us a clockwise moment, all these terms are assumed as a positive. If a force is going leftward, downward and giving anti-clockwise movement, those are negative. So we'll work out summation fx. As I told you earlier also, summation fx is nothing but a algebraic summation of all forces, that too in a horizontal direction. So two components of this P will be like this. I'll name it negative P cos theta. Why? Because in resolution of forces we have learned, if inclination is given with horizontal component will become cos, and it is acting in a leftward direction, as I have mentioned over here, it will become negative. So this force is over. This is purely vertical force, can't reflect in a summation fx. This is a horizontal force, positive U. This also will not get reflected in a summation fx. Here two components will be like this. So positive s cos theta is there. Then summation fy is equal to, from here I'll start negative. Why? Because going downward. P sine theta, right? Then minus V, U will not be there in summation fy, plus T, then minus S sine theta will be there. So in this way, we have worked out summation fx and summation fy. Let me tell you one more time for summation fx. Summation fx is a algebraic summation of all horizontal components. How many horizontal components are there in a given force system? This one is a horizontal component. This one is a horizontal component. This one is a horizontal component. Again, this one is also a horizontal component. We must mention it minus q because it is going in a leftward direction. Then we'll move on for summation fy. This is a this will contribute to summation fy. Negative p sine theta, negative v, positive t, negative s sine theta will be there. So in this way, we have learned composition of forces. I told you that law of parallelogram is useful for only two forces, that too they are concurrent. Then and only then we can go for that. And general method is happily used for any kind of force system. Okay, that's all from my side. Thank you for watching. Happy learning.